We are talking about multithreading. We've answered a whole bunch of multithreading questions in our last break here. And we will be answering even more as soon as we're done with this section, which is not far from now.
I hope so, yeah.
Just a final question over here. How do I solve this puzzle? Now we've seen the problem. What is the correct way?
Well, there's two ways of doing it. The one we explained earlier is actually creating the stuff in run without parent, and then the objects belong to the right thread. Since Qt followed 4, there's another option. Run is no longer pure virtual, but by default calls exec. So if you just create a Q thread and start that without inheriting from it, you get a thread that has its own event loop running. And if you move objects to that thread and have signal slots connection between them, they will be executed in that thread, and you won't run into these problems. So for many use cases, that is probably fine. But there are still scenarios where we might need to inherit Q thread, and then you, of course, need to keep this stuff in mind. Still, this is very relevant if you have code that still uses this approach, or for whatever reason uses this approach, even in newer Qt versions. If you forget in which thread your objects are, you will get all kinds of funny results. So that's something important to keep in mind.
OK, final issue here in our multithreading section is synchronization. And let's just get into it. Synchronization is, as those of you that has just been to the first lecture on multithreading, of course, an important issue in multithreading. It is to avoid that two threads are writing to the same resource at the same time, whatever writing and whatever resource means here. And the way that you solve this in regular C++ multithreading, not even Qt, is with mutexes. And we have a class in Qt called QMutex. Pretty simple.
Yep.
QMutex has a method called lock and another method called unlock. And if one thread is trying to lock a mutex and it's already locked, well, nothing will happen until whatever has it locked unlocks it again. Pretty basic.
Well, and nothing will happen means the thread will actually stop there until the other one unlocks the thread, the mutex.
We have a method in QThread, in QMutex, called trylock. So if you, for some reason, want to try and lock your thread, you can do that with trylock and then a timer. And if it hasn't managed to lock it by then, it'll jump out of the trylock and the thread will continue for whatever reasons you might want to do that.
Well, since lock completely freezes your thread, you might just as well use the time to do something useful while waiting for the other mutex to be unlocked.
Yeah.
OK.
Here's a, let me just draw it up here. See, a problem with software development is not writing software, it is maintaining software. And here's a bit of code. I have a function here. I have a mutex. Gee, this is thick. Lock. I have a bunch of code executing at the end of my execution. Just before I return, I will say mutex pointer unlock. Works great. Our application is ready to ship. Everything is fine. Now our intern, Volker, comes around. He's not that good at reading software, obviously, because he just makes a small bug fix in between. My previous function not returning anything now is returns a false for some reason. And this is a typical error that you'll find in software. What's the solution, Volker?
Yeah, the solution is a nice convenience class called QMutex locker, which takes care of the locking and unlocking of the mutex for us. And that's yeah, a tiny little helper class where you create an instance of on the stack. And yeah, that object will be destroyed as soon as you leave the block in which it was defined, by whatever means you leave that block. So that could be an early return, that could be an exception that is coming from somewhere, or you just run out of the method. And whenever the destructor of that object is called, it will unlock the mutex automatically for you. So with that, it doesn't matter what kind of return or exceptions I add in between, the mutex will always be unlocked. And that's actually a very nice pattern that you can use for all kinds of stuff that needs to be closed or freed up at the end of a function, no matter what happens in between.
Just a small trick. Whenever I start a new project, the first bit of code I write are two down this road. One is called Q signal blocker, that in its constructor called block signal, and in its destructor calls unblock signal, or block signal will false. And the other one is Q busy cursor. Excuse me, Q busy cursor, which in its constructor calls set override cursor, and in its destructor calls restore override cursor. Then I don't risk that I'll return while I still have the busy cursor in my application and have that stuck. So,
yep,
little nifty thing. Okay, read-write logs.
Right. So what we've seen in mutex, that's a complete exclusive log. So only one thread at a time can access the data structure you protect with it. But quite often you have data structures that are safe to read, for example, by being read simultaneously by multiple threads. But you can only write them in a single thread. And to achieve that, there is the read-write log, which you can either log for reading, which is a log that is handed out to multiple threads simultaneously, or logging for writing, and then it waits until all readers have been finished, and then exactly one thread gets the write log. API is similar to mutex, so we also have the try log variants, and we also have the convenience classes you can use for safe unlocking, read locker and write locker.
Why wouldn't I just always use that then? Instead of mutex? Why not just always use a Q-read logger?
It's more expensive than a simple mutex. And for this to be actually useful, you need a scenario where you have multiple threads that actually want to read simultaneously. So you need at least 3 threads being involved until this starts to make sense. If you just have 2, one wants to read, one wants to write, you can just as well use a simple mutex.
Yep. We also have a class. Have a class called.
I think I mentioned that.
You did already?
Yep.
Okay, sorry. We have semaphores, just like we have mutex, that is just a single resource that you lock. If you have a number of similar resources, that is in regular multithreading called a semaphore. And we have a class for that in Qt. Q semaphore, amazing naming. You will again lock and unlock, except this time you call acquire and release. But apart from that, it's the same thing. Try, acquire, and try acquire and the acquire. They take an optional parameter telling you how many you want to acquire. So if you want to try and acquire like 5 resources for whatever, then you can specify that as a parameter. And here's a bit of similarities or difference between a mutex and a semaphore. If you don't know what a mutex and semaphore was before I started talking about this, this is not the right place to learn about it. And if you know what they are, then yeah, you already know that.
There doesn't seem to be a Q semaphore acquirer along the lines of the mutex locker classes. That would be helpful.
Waiting for events.
Yeah, that's the final locking mechanism. We have Q-wait condition. So if you have to suspend a thread while waiting for something else to happen, that's what Q-wait condition is for. So the thread you want to suspend calls Q-wait condition wait, and then it will be stopped at this point until another thread calls queue wake condition wake 1 or wake all, so you can have multiple threads suspended at the same time. Yeah, that's whenever you have threads that wait for whatever input they need to do their processing. There's one slight surprising thing in there, and that's that wait takes a locked queue mutex or a read-write lock. That's basically to avoid a race between wait and wake. So you don't want to have wake being called before wait is actually taking effect, and you wake up a thread that is not going to sleep yet, and then it will call wait afterwards and sleep forever. So you need to make sure this happens in the right order, and for that we need another synchronization primitive like a mutex or a read-write lock. Okay.
And final section here, miscellaneous. The first thing is thread local data. We have this great concept of global data in our applications, and that's great. They are global among all of the application. Then we have very local data. That's the variable that you have in your methods. But it would be awesome if you could have a global variable that was global for a thread, but you have one variable per each thread.
Right, and that's exactly what queue thread local data, queue thread storage gives us. Typical use case is something like a per thread singleton. Like the singleton pattern, right, where you have an object that only exists in one single instance in the entire process. But there's some cases where you actually want something that exists exactly once per thread. Think about stuff like database connections. So you usually can't do database queries on the same connections coming from different threads, but you only want one connection per thread. So you can have a per thread singleton that manages your database connection. And to implement such a per thread singleton, there's queue thread storage, which allows you to do that. It's basically like a global variable that has different content in each thread. Okay.
There is if you ever want to try play with that, there is a number of caveats listed on the in the documentation for queue thread storage. Go and check those out so that you don't get into some of those problems. But
yeah, but they are not really that relevant in practice. I think you can only store pointers, and you can only have 265 instances of queue thread storage depending on platform. For the typical use cases of per thread singletons, that's rarely something that gets into your way.
Fair enough. A few final tips and tricks here. The first one, do not attempt any GUI operation with in-queue or circumventing queue from another than the main thread. So on a secondary thread, don't do anything that goes to the GUI. Why is that? Well, because the GUI could be your X server, and your X server is anything but thread safe.
Oh yes. So that will most likely crash, and Qt is full of asserts that will terminate the application if you actually try that. Still, it's not really a problem if you just connect a signal coming from a different thread to a widget like a progress bar, because that's safe. As we saw earlier, the slot is actually executed in the GUI thread. This is not a hard limitation when it comes to updating your UI from a secondary thread.
Yep. And among the same kind of lines, don't create any resources that belongs to GUI land. Right. That would be widgets or pixmaps. Pixmap is a resource that you might or might not know is an X on Linux. It's an X server resource that is allocated there. So again, you will have a nice way of terminating your application.
Yep. And okay. Yes, similarly. The memory management first. I mentioned earlier that run behaves sort of like main, so stuff you create there should be deleted when you leave that method. There's one difference though. If in main you are leaking memory, like creating something on the heap and not deleting it, well, when main exits, your process will be destroyed anyway and all the memory will be freed, so you're good there. That might be different in a thread swift, because you might destroy the thread recreated multiple times in your application, and if you don't clean up everything you created in that thread, it will actually be a real memory leak. So either create stuff on the stack in run, or delete it when you leave that method again, or use a smart pointer for that.
And finally, we'll end on a high note. If anybody is surprised by this next bullet point, you are in the wrong class for sure. Don't block in a thread. Well, don't block in your GUI thread, because then your user interface will not update. So if you're like in a slot and you start, if you like, try and acquire a lock on a mutex and it's locked for 10 minutes, then the GUI thread will not run, which means it will not refresh your screen or do anything else. So don't try that.
Right. If you want to get to data from your thread in the UI thread, the much nicer way is to just connect to a signal that's thread safe, so you don't need to use the locking stuff, which might actually block the thread, and you still can update your UI thread easily.
So that's an example actually of something where the try lock might be a good idea. So right. Remember mutex try lock, instead of just on your GUI thread say mutex lock and wait until it's locked and then start reading some shared resources. Do the try lock. If you didn't get to do it, go back to the event loop so the user interface can update and try the try log a bit later down the road.
Yep, that's a very good example for how to use that. Yeah, and finally, that's hardly surprising as well. You can't execute the event loop for the GUI thread in a secondary thread. Again, anything that touches UI-related stuff needs to happen in the main thread. OK.
I guess that was it on multithreading. Hit us with all your questions. Brunner. I know that there are questions out there. I think we already answered a bunch of them during your break. So did we answer all of them? We have a guy up front.
I'm going back to the beginning. I'm not quite sure. Am I correct when I'm saying that reentrant is implicitly thread safe, but not everything which is thread safe is necessarily reentrant?
No, it's the other way around.
OK.
So reentrant means execution of the same method on two different instances simultaneously. But thread safe is the stronger guarantee that you can run the same method on the same instance of the object simultaneously. So it's like, let's take an example.
Let me show you the non-reentrant thing. So you,
okay.
Gee, that's green. Good old version of Q string. What is Kent? Printf.
Printf. Yeah.
Some arguments here. Inside there, it has a static char data 200. I'm just making up code here. I wouldn't expect it to be that stupid. But anything like that, right? And then you do something on two different threads. These two different threads would go for this global variable. So that obviously is not reentrant. At the other extreme, something, if this one was, an example would be Q string append. So appending data to a string. If that one is reentrant. It's not going to something. So two different strings I can append to. But I cannot, on the same string, append to that string from two different threads at the same time. Why is that not thread safe? Well, if that was thread safe, then inside QString, : append, Qt would need to lock so that two threads couldn't do that with a mutex. which will be a huge penalty. Locking a mutex is an expensive operation, so that would be a huge penalty for all those situations where you were not trying to append to a string from two different threads. Did that answer your question?
Yeah.
Okay.
There's one thing that is actually thread safe in QSwing though, and that's the ref counting when you actually make a copy of it. And that's why it's safe to copy that into a different thread, which, for example, happens in signal slot connections. So all the implicitly shared types in Qt are safe to copy into a different thread.
You didn't even know that was a problem, huh? That the Q string, you might or might not know, they are reference counted, which means that if you have a string and you have a, let's take a better example, Q image. I just take an image, a picture of you with my new camera that can do terabytes of images, and now I copy that thing. I have a Q image of 1 terabyte, I copy that to a new image. That doesn't mean that I'll have 2 terabyte memory because it's reference counted. But hey, if I copy something with a reference counter, I could be copying that image on 2 different threads, and I would be doomed if it wasn't for the little bit of assembler code for each and every single platform that Qt supports. There is a bit of assembler code that can do an increment as a single operation.
Yeah, that's Q atomic int, which is the third section. We didn't get to that in the multi-threading training.
Where's my microphone guy? Over there? Microphone guy? Oh, you got the microphone already.
But it's off.
Yeah. That does not work. Oh, he broke it. Thank you very much. So the next section will be... Not working.
Testing.
Whoa.
Let's say we have 2 threads and one calls invoke method on the other. And is there an option to cancel such an invoke method?
I don't think so.
Well, first of all, a thread doesn't call an invoke method on another thread. It's just a static method, invoke method, specifying the receiver of that. That's just a tiny detail here. So it's an invoke method, specify the object that's with the receiver, specifying the method that is to be invoked on that receiver. Any way of canceling it? No, I don't think so. No.
It's an event loop. You can't even access the stuff that's in there.
Right. Why would you want to do that?
Well, let's say you have a map application and then you pan, you have kinetic panning, and at some point you request tiles which are not needed anymore, and then you have to wait until those tiles are processed, and then you see a black screen. And
right. So you just want to avoid that your secondary thread, for example, is doing a lot of calculation on data that's not going to be displayed anymore.
Yes.
Yeah. I would do that with a shared resource, which was a set of data still needed, and whenever it's not needed anymore, take it out of that set, and then finally, when it got to do the calculation in the secondary thread, go and ask the set, is this still needed? And if not, just not do your operation.
Yep. That's good.
Yeah. Somebody over here, right, so he can run. No, I'm just kidding. Anybody else? Ten, 9, 8. I have a vague feeling we're carrying on now.
Okay.
Okay, there is an exercise in here too. Again, go home and try it out. We're a bit late here already. So go home and try this exercise. It's a pretty fun exercise. It is an exercise where you are about to create a multi-threaded thumbnail viewer, and the multi-threaded thumbnail viewer needs to fetch those thumbnails on a secondary thread to avoid that your GUI thread is blocking.
Right.
Pretty fun.
I think the handout also contains the solution, so they can...
Yeah. On the keyring that everybody got when you signed up this morning, all the examples we show up here will be on that keyring. And on that keyring, you'll also find the handout and the solution for this exercise here.